All right, first when I'm simplifying, I'm looking to take out any perfect squares out of this number. So I'm going to just start by factoring. What are two numbers that multiply to 90? I'm going to just start with 9 and 10. I right away observe like, oh, 9, yes, that's a perfect square. That's 3 times 3. Right? And when I get to any prime number, I circle it. Okay, 5 and 2 are also prime. So this becomes, now what I'm going to do is I'm going to list my doubles together. So that way I can easily see them. Because what happens to these doubles, right, is if I separate out these doubles, these can simplify. Here's why, right? 3 times 3 is 9, and the square root of 9 is just 3. So this is 3 squared and square rooted. That's just 3, right? That's just like something being done and undone. Now this, 5 times 2, those are singles, okay? They just stay singles. But when they come down here, since they're both singles and they're both going to stay in the house, they get multiplied together. So 5 times 2 is 10. Let's take a look here. It's going to start the same. I'm going to start by factoring 12. I'm going to go 3 and 4. 3 is prime. 4 is that perfect square that I'm always looking for. Now watch, I'm going to make this nice and long because I'm going to list my doubles first. Make sure they're together. And then my 3. Now look, I'm going to list these out. I'm going to list x, x, y, 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 y. Okay? So, double. Look, single. See how neatly and clearly I'm marking these so I don't lose track of anything, right? This is double, this is single. Double. Look, double y, single y. Okay? So, now, here's what's going to happen. Look, I'm not going to write all this out, but we know what happens. Look, this is going to become, look, I'm going to write it just so I can explain it. This is going to become this in its own house. What does that become? That just becomes a 2. What does this become? This becomes an x times x in its own house. What does that become? Just 1x. This becomes a y times y in its own house. What does that become? Just a y. What does this become? A y times y in its own house, right? What does that become? This is y squared and square rooted. That's just a y. Now, what's left, I just got all the doubles. What's left is this 3y. Okay, now look, I hope on the quiz that you don't write out this step, that you just know the doubles are going to come outside and the singles are going to come inside. Okay, and then let's write this better, right? We don't write y times y. If we want to write y times y, we write y squared. Okay, last one. 7 is prime. Okay, watch what I'm going to do before I start writing anything. I'm going to take this 3x, I'm going to put it right here so I don't forget about it. Okay, now let's do this. So here's what's on the inside. A 2, a 7, and 3 x's. So I'm going to do my regular. This 2 is double, single, double, single. Okay, so look, I'm going to skip this step this time. I know that the double becomes, right, this becomes this, the same as this. That becomes a 2 on the outside. This becomes an x on the outside. And then on the inside, what's left? This 7 and this x. Okay, now I'm going to multiply, right? I'm going to bring this 3x back into it. 3 times 2 is 6. Okay, and then look, x times x. Don't forget this x, okay? X times x is x squared. Okay, only one x came out, but there's this other x that's already out here. And that doesn't touch anything on the inside. This stays 7x. For these estimating questions, I want you to use your tools. If you remember when we first learned it, we had these notes and we had a number line and it was like 1 was the square root of 1, 2 was the square root of 4. That number line is right here. Here it is. I'm providing it for you on the quiz. Look, this is 1. This is the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Look, it's right there. Okay? I've purposely given you a multiplication chart that has the perfect squares highlighted, and you're going to have this same thing on the quiz. This is exactly what the quiz looks like. So if I'm looking for 99, what I'm going to do is I'm going to go to my number line and find 99. Where's 99? Oh, it's right here. It's right before 100. Okay? It's in between. Look, it's in between 81 and 100. It's really close to 100. So it's in between 9 and 10. Look, it's really close to 10, right? The square root of 100 is 10, so the square root of 99 is going to be just below 10. What's a number in between 9 and 10 that's really close to 10? A good estimate here would be 9.9. Okay, how about square root of 30? Look, let's find it on my number line. Here's my number line with all my squares. Okay, 30 is, let's see, it's right here. It's actually kind of like halfway in between 25 and 36, like pretty much halfway. Okay, so it's in between. The square root of 25 is 5, and the square root of 36 is 6. So the square root of 30 is going to be in between 5 and 6. And like I said, it's kind of like halfway between. So what's halfway between 5 and 6? 5.5. Right? And let's factor a little bit. Don't get bonus points too much on a quiz. Here, I notice that there's just one x out in front, so I know right away I can do this. Okay, I notice that I'm multiplying to a negative. So the only way is to have a positive and a negative. And what I need is two numbers that multiply to negative 88 and add to 3. Now, because I have a positive and a negative, what I need is two numbers that multiply to 88 and subtract to 3. You can use this. Okay. What I really like about numbers like 88, 77, 66, 55, 44, they're always multiples of 11, right? This is 11 times 1, 11 times 2, 11 times 3. So love those. Here's 88, and 11 and 8 are going to totally work for us because 11 times minus 8 is 3. And I notice I have positive 3, so this is going to be 11 times 8. And I want to make there be more positives than negatives. So I'm going to take my larger number and I'm going to make it positive, smaller number, make it negative. Okay, here, I notice there's not a 1 out in front, so I first ask myself, is there a GCF? Is there a number that multiplies to 5, 27, and 10? And I think, oh, 5. Oh, no. Nope, there's no GCF. So I'm going to set up my parentheses. I know that this times this equals this, and this times this equals this. And then in order to get that middle term, I'm going to have to multiply this and add them together to check. So first, let's start with this one. I know this times this equals this, so that has to be 5x and x. For multiplying to 10, I could do 10 times 1 or 5 times 2. Let's start with 5 and 2. I notice I have all positives, so I'm going to go ahead and write positives. So far, I'm writing dark. I'm sure about everything. Now I'm going to start writing a little bit lighter. I'm going to put a 5 here and a 2 here. That's 5x times 2. That's 10x plus 5x. That's 15x. Nope, that doesn't work. Okay, let's try switching them. That's 5x times 5, that's 25x. 2 times x, that's 2x. And that's 27x. That's it. That's my answer.